Okay, this is section 14.2, and we've got a couple of rules that we need to get down. The rules are in blue, and they're limit rules, and you really just need to know them. You don't necessarily have to quote the rule, you have to know what they mean. So there's an example in green for the rule. First one says you've got a function, f of x equals b. What kind of function is that? B is a number, so y equals a number. Yeah, that's just a horizontal line, a constant function. So regardless of where you're approaching, what's the y value? B. Yeah, because if you've got, say if you say y is 7, that's what that means. Y is a number. So if you say the limit as x approaches 3 of 7, it's still going to be 7, right? There's no plugging in. You've got a horizontal line here, and so here's your y-axis down here. But here's your function. As you approach 3, what's the y value? Whatever that is. As you approach 9, what's the y value? That same number. So regardless of where you approach, you're going to have that y value. Does that make better sense, maybe? If I could draw right and have a big eraser so that I could get rid of it. It's used to telling my kids. Okay, so that's if you have a constant function, y equals b. How about this one? We have f of x equals x. So the rule says as x approaches c for the function called x, it's always going to be c. In other words, the limit of x as x approaches 3, well, you just plug in and you get 3. So it's always going to be your c value. That's the rule. Here's the example. Does that make sense? Sort of, kind of.
It's just the same thing. Just plug in for x, and so if you plug in for x, when all you have is b. I mean,
yeah.
So x is 0 there. So there is no x.
There is no x, so you can't plug in.
Yeah, so you can't plug in.
Yeah. Absolutely. All right. Here's the actual rule for polynomials. The limit as x approaches c of some polynomial function is equal to p of c. That means you're going to plug c into the polynomial, which is what we were doing already. Okay, so here's an example. The limit as x approaches 2 of this thing, you plug in 2, you get 2 squared is 4, minus 10 is negative 6, plus 7, you get 1. So if you have a polynomial, there's no reason you can't plug in. The problem comes if you have a rational function. Sometimes you can't plug in because the bottom goes to 0. So rational functions have problems, but polynomial, you're fine. Just plug in. That's okay, because your limit could be 0, but on the bottom it would make it undefined, so you can't do that. All right, this rule, the limit of a power or a root, you're just going to plug in, okay? If you have the limit as x approaches c of some function raised to a power, you can take the limit of the function and then raise that limit to a power, okay? We'll write an example of that. If you're writing, you can get that down and then we'll go from there. So it's saying if you have the limit of some function to a power, you can find the limit of just the function. Whatever you get, then raise that to the power. So let's look at the example here. All right, the limit as x approaches 1 of 3x minus 5 to the 4th. Well, let's take the limit as x approaches 1 of 3x minus 5. We can plug in 1 and we get negative 2. If we plug in negative 1 there. Well, then negative 2 to the 4th power is 16. That's all it's saying. And then we have one with a radical. The limit as x approaches 0 of this radical we can do it this way. We can put it inside and say the limit of that, what's the limit if you put 0 there? 8. So the square root of 8 is simplified. It's 2 square roots of 2. And you don't have to do this. It's just saying sometime in your life it might be helpful, so it's allowed. That's what it's about. But right here we can just plug in 0, and we get the square root of 8, which is 2 square roots of 2. Okay. And then we have this power that's a fractional exponent. What does that mean? Cube root of something to the 4th. Okay? So if you plug in -1 inside here, if you do all that, -1 cubed is -1. So that's -5 plus 1 is -4 plus 3 is -1. -1 to the 4/3 is the cube root of -1 and then raise it to the 4th. Or on your calculator, you could just do -1 caret parentheses 4 divided by 3, and you'd still get 1. It's usually easier to do the root first. And now in 1, it's not a big deal, but if you had a big number, like 256 to the 4/3 or 3/4 or whatever, you would want to take the root first and then raise it. It'd be easier. Shouldn't. All right. Limit of a quotient. And that's not, we're not at derivatives. We're not doing the quotient rule or anything. It's just the limit of a quotient. Says, as you approach C of this quotient, you could break it apart to the top and the bottom. You could find the limit at the top and the limit at the bottom and then divide them. Okay? So on our example, we have the limit as x approaches 1 of that quotient. You could just think of it, you could put it all in at once, but you can think if I take the limit at the top and I plug in 1, you should get 6. And then if I do it on the bottom, I get 7. So my limit is 6/7. Okay? But you could just plug in. Just kind of showing you the rules and how they work. For more complex things, the rules might come into play. Any questions? We're not awake. It's Monday. All right, let's do some problems. Okay. All right, these are using the rules that we just had. All right, the limit as we approach 7 of -8. What's that going to be? -8. Oops. The limit of x as we approach 1. 1. The limit of 6x as you approach 2. You're just plugging in. So 6 times 2 is 12. Okay. Find the limit algebraically. X approaches -6. There's no problem there. Let me make those a little bit bigger. So you're just plugging in. What do you get? Okay. The next one, did I go too far? As x approaches -1. I think 9. Okay. And the last one. See what you get on the last one. Okay. So those aren't bad, right? Okay. Now, these we start having to do some algebra on them. Some of them. All right. Oh. All right, the limit as x approaches -2. We're going to plug that in, and what do we get? Square root of 13. And you don't want to put a decimal, you want to put that. And it says as a simplified radical. So if 13 could have been simplified, we would have done that. All right. On this one, this is where if you direct substituted, you would get 0 over 0. So you can't do that. So that's your key and your clue to go factor if you can. X squared minus 1 factors to x minus 1 and x plus 1. X squared plus x, you can pull an x out, you get x times x plus 1. Those cancel. Now you can plug in -1, because on the bottom that's not going to be an issue. So you do it, and what do we get? 2. -1 minus 1 is -2 over -1 is +2. Okay? And I've written the factoring out. There's one down here that you probably would not remember how to do, but you're going to have to factor these when you do your homework. And I would suggest not letting your homework build up, because it will get worse. All right, the limit as x approaches 5. Well, I can't plug in 5 because that would be 0 on the bottom. So factor the top. You get x minus 9 and x minus 5. On the bottom, it's x minus 5 and x plus 5. Cancel, cancel. Well, now 5 can go into this bottom part. So you have -4 over 10, which reduces to -2/5. Okay? All right. This is one that I said you probably wouldn't remember. The sum or difference of 2 cubes. Do you remember how to factor those? If you don't, here's the rule. Take the cube root of x cubed. What is it? It's x. What's the cube root of 64? 4. The sign matches. So you have x plus 4. Then you can build the other part. Square this one right here. Square this one. That goes there. Inside, you multiply these together. That's your 4x, and you switch the sign. So that's the way sum or difference of 2 cubes factors. You can look that up if you forget it. The difference would be if you had x cubed minus 64, it would be x minus 4, and then when you built it, you'd have x squared, and you'd have 16, and you'd have 4x, but you'd have a plus. Yeah.
What would the sign on 16 be?
It's always plus because you're squaring. Yeah. So you actually do need that one. You never think you're going to need it from algebra because you don't use it a lot, but factoring, you do need to kind of get that. So at any rate, those went away, and we're left with this. So when you plug in -4, what do we get? Some of us maybe wake up and try that or something. I think it's 48. Yeah, you're doing it in your head real fast. Yeah. All right. On the bottom, we can't plug in 1, so we know to try and factor. So I did the factoring, and I end up with x minus 1 over x plus 1. So that's okay on the bottom. I get 0 on the top. That's okay. I can have a limit of 0. So you will have to kind of remember your factoring for this little exercise. Okay. Questions? The last two have some other factoring techniques that maybe you haven't thought about in a while. This one has 4 terms up here. And we couldn't plug 1 in because it wasn't going to let us do that. We'd get 0. When you have 4 terms, you want to think about grouping. So if you look at x cubed minus x squared, what's common? X squared. So I pulled out x squared, and I got x minus 1. And then on the other one, I'm trying to make this match. So if you just think about it, it does match. So I've got a 1 outside it. If you could pull out a number, you would. All right, then these two go together, and these two go together. So it's x squared plus 1 times x minus 1. That's how that factors. Same thing on the bottom, and you end up being able to mark out those two, and you have x cubed plus 1 and x squared plus 1. Plug in, let's see what you get. What are we approaching? 1? Yeah, 1. What's it going to be? Is this a standoff? What? Yeah. Because you end up with 2 over 2? Yeah. Okay. All right. Same thing on this one. You had to use grouping to do the top, and you ended up with x squared plus 4 times x minus 2. You factored the bottom, and you get x plus 3 and x minus 2. Cancel out, and you've got x squared plus 4 over x plus 3. As we approach 2, what will be the limit? So, any questions on using those rules? And most of it's direct substitute. If you can't, then you can factor.